And our session co-chairs, besides me, I'm Bob Downs. We have Kirsten Leonard, Lily Zhang, and Devin Ray Donaldson. And I'm from Columbia University. And we also have Kirsten Leonard from Columbia University, from the Lamont Doherty Earth Observatory. We have Lily Zhang from the Computer Network Information Center of the Chinese Academy of Sciences. And we have Devin Ray Donaldson from the Luddy School of Informatics and Computing and Engineering at the Indiana University of Bloomington. So just a brief introduction to our interest groups. The chairs of the Repository Platforms for Research Data Interest Group are Lily Zhang, Devin Ray Donaldson, and myself. And then the chair of the Domain Repositories Interest Group is Kirsten Leonard. And just briefly, the Repository Platforms for Research and Data Interest Group is trying to improve the usability and technical capabilities of repository platforms. And the Domain Repositories Interest Group is sharing interest in data curation, dissemination, preservation, and institutional sustainability. They're providing a forum for sharing practical experiences and developing joint projects. Did I skip ahead too many times? Yeah. So our agenda for today is, after this brief introduction, I'm going to introduce the progress on the data review discourse. And then Andrea Thomer is going to talk about workflow perspectives on data review, followed by Martina Stockhouse, who's in person here. And she'll be talking about approaches and challenges of reviewing research data in climate science. And then next, Kirsten Leonard, who's also online, will be talking about implementing Astromat data review. And then Devin Ray Donaldson will be moderating the discussion. Devin Ray is online, so we'll be walking around here too with microphones to facilitate the discussion. So just some initial questions for us to consider today would be, how can data repositories conduct data reviews more efficiently? And how can they prepare internal reviews and recruit independent volunteer reviewers? And how can data repositories coordinate to improve their data review practices? With that, I'm going to talk about the progress on the data review discourse. And basically, we could talk about various topics such as automated or semi-automated data quality inspections, data curation assessments, looking at data quality, peer review of data, final curatorial review, managerial oversight of the review process, ongoing community reviews of data. And then I want to touch on artificial intelligence assistance with data reviews, because that's a new opportunity for us. So in terms of the automated or semi-automated data quality inspections, we want to have a curation team that is improving efficiency. Well, we want to support them to improve the efficiency and reduce costs. And so the curators can work to identify any parameters that are needed. And they can certainly review the reports generated by the automated or the semi-automated processing. And this way, with the help of the machine processing, we can ideally make that so it's less labor intensive. And then we can leverage the technology by parsing the metadata to ensure that the schema is in compliance with whatever schemas we're using for metadata, and that the required fields are in fact complete, identifying missing values, and making sure that the variables values are within the ranges. And we want to also If we can use the parsing to validate the formats for the data, documentation, and any source code that might be available. And also looking to ensure that the source code is documented. And we could also use that for ontological identification of terms so that perhaps additional terms could be added to enable discovery across various disciplines. So for the initial data curation assessments, there we would want to have just a general curation review. And if it's a domain-specific repository getting domain-specific content, we would want to have that curation review to be domain-specific as well. And we wanted to verify that the metadata and the documentation are in fact understandable by the user community, and that we have the data provenance, that is any processing, validation, the time period when the data were collected, as well as the coverage represented by the data. And then we would certainly want our intellectual property rights to be in line so that we can facilitate open data, if you will. And then we want to have compliance with any repository standards in terms of the scope and formats. And we should be able to communicate with the data depositors as we identify any needs for either clarification or corrections. And likewise, we would want to include any acknowledgements in the metadata and in the documentation for any sponsorships or and other contributions. So looking at the peer review process, we want to have the criteria so that the experts can conduct the peer review. We would have to implement a system to facilitate that, and any applications and tools to administer the peer review process, and of course have instructions for the peer reviewers. And often overlooked is the incentives and the rewards, ways in which can recognize the peer reviewers for their work. Often these are volunteers, and they're certainly not getting enough credit for their work, and it can be very time intensive, often more time intensive than reviewing an article for publication. We would want to establish a pool of candidate data reviewers, which means we've got to get all the different areas of expertise represented for the different kinds of data that we expect to receive, and then be able to invite those independent external reviewers to take on reviews of the particular data products that are related to their expertise in terms of the methods and instruments that were used. And then we want to have the peer reviewers look into the usability, ensure that not only the scientific members who are experts in that discipline can understand it, but also others, perhaps who are coming from other disciplines, depending on the audience of the repository, of course. And then we want to offer general guidance for data peer review in terms of, consistency, and if there's any divergence from previous studies, we would want to see that justified, so there's an understanding of why a particular methodology or instrument was adopted, for example. And then we want to have documented references to any relevant literature, especially if we're looking at the methods or related data products to the one that's going to be disseminated, and make sure its accuracy, and also that we have scientific applicability, and a description of any limitations in terms of the potential uses of the data. And for our final curatorial review, we want the curators to be able to organize the various comments received and any suggestions, and to summarize those that are redundant. Perhaps they could put them into categories, and then uh, they can resolve any contradictions among the reviews. We often see, for instance, when we're looking at reviews of published articles, one reviewer will say this, the other one will say, don't do this. And, that would have to be resolved for sure. And then any completion checks, they should be generated so that we know that at the end of each stage, we have completed that and we can move on through the review process. And then the curators also need to address any comments from the peer reviewers. And that might mean comments where the metadata or the documentation are not complete, or they might have to actually ask the data producers to make some corrections to the data. And they also might have to ask developers to improve the capabilities of certain tools or add certain features to them, as well as to the services. And then if there are any issues regarding the use, applicability, and limitations, the curator should certainly make sure those are described adequately in the documentation. But we also need managerial oversight of the review process. So certainly there can be a pre-release managerial review where they're doing the quality control inspections and verify that the accessibility is in fact working, and not only for the data, but any tools as well. And they want to also make sure, working with the curation team, that everything has been completed. And some repositories actually have a configuration management board as well. And they would conduct a review to make sure that any items that were overlooked in the previous reviews are caught and addressed, of course. And then they would also ensure that review issues have been sufficiently addressed. But we also want to rely on our user community. After the data are released, the user community can be a valuable source to determine if there are any issues with the data. And so we can have ongoing interactions with the user community where we describe the availability of the data, and we support their use if there are any issues with it. But the community members also can share their experiences. They can offer comments and questions on the use of the data, and such comments and questions are certainly valuable for being able to either add to the metadata or add to the instructions or correct any. Oh, we lost power. Oh, oh, okay, rebooting. Okay. Is it just this building? Can you hear us? Okay, well, can they hear us online?
Yes.
They can. Okay. Well, we will continue. Hopefully, people online will be able to follow us. Get and finish my presentation at least, and then. So the last issue that I was going to talk about is the artificial intelligence assistance. So we know that artificial intelligence is becoming much more usable in the recent couple of years. And so we might be able to improve our capabilities by adopting AI for the review process. And so one question we might ask ourselves is, how can AI reduce demands on the reviewers? That is, if we can program or at least pose the right questions for AI, maybe
Recording in progress.
Please bear with us. Oh, 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 Okay, the echo? No, the echo is off? Oh, okay. So, yeah, the clicker doesn't seem, oh, there we go. We're moving along. Okay, and so We might ask ourselves also, how can the repository evaluate the artificial intelligence approaches that might be appropriate for reviewing data? And how would data be prepared for review by AI? So it might be more than just posing the right questions to the AI. It might be that we need to prepare the data, format it or something so that we can get the most out of the AI. And then how would we evaluate whether the data are in fact ready for AI review? And how can the results of data reviews by AI be interpreted and trusted for that matter? And then finally, what techniques can verify the results of AI data reviews? And so with that, I would like to, just 1 second here. I would like to move on to our next speaker who's online, and that's Andrea Thomer. And she's going to talk about workflow perspectives on data review. So Andrea, can you hear me?
Yes, can you hear me?
Are you online, Andrea?
I am, but I don't think you can hear me.
She is. Oh, okay. So please, can we have Andrea's slides up on the screen? The slides for Andrea Thomer.
I can also project from my computer if you make me a co-host.
Can we have the slides for Andrea Thomer on the screen? With this? Oh, Andrea, you need to share your screen apparently. And put your presentation on Zoom and share that. Can you do that, Andrea? Oh, there we go. Okay, Andrea, we can see your presentation. So please go ahead.
Can you guys hear me okay in the room?
If you're speaking, Andrea, we cannot hear you. Do we have to unmute?
I'm unmuted. I think the people in the
Recording in
Zoom-
progress.
So I think the folks in Zoom can hear me, but not in the room.
We hear you now.
All right, great. Let's see. Okay, great. Hi, everybody. All right. Hi, my name's Andrea Thomer. I'm an associate professor at the University of Arizona College of Information Science. And I've tweaked my title for this talk just a little bit. So I'm calling it Complicating Workflow Perspectives on Data Review, the Craft of Curation at ICPSR. And I'm presenting findings from a paper that we got published about 2 years ago at the Conference for Computer-Supported Cooperative Work. So a little bit about me. There was an echo there, but I'm going to ignore it. Yeah, like I said, I'm an associate professor at the College of Information Science at UA. I studied. Okay. I'm getting a lot of feedback, and I don't know if that means I need to mute or somebody in the room needs to mute. Okay, I'm going to try to go again. Okay, so I'm an associate professor. I study knowledge infrastructures. Most of my work focuses on natural history curation, but I'm also involved with a couple of projects at the Inter-University Consortium of Social and Political Research, which is what I'll be talking about today. That's ICPSR. This talk today, like I said, is presenting work from a previously published paper that came out of two grants. One was I'm doing the best I can. So two grants at IPSR. Figure this out because it's really hard to talk through. Okay, it looks like it stopped. So these were two paired grants, one from NSF, one from the Institute of Museum and Library Services in the US, both looking at the impact of data curation. So the first one, the NSF grant, our core research question was how can data repositories best allocate their very limited resources for different aspects of data archiving and processing? The second from IMLS was asking what curatorial actions most impact the use of digital collections and which actions generate the most benefits. And I also want to make sure to point out that this was obviously a huge team effort, and I was one of several PIs and one of a large member, one of a large team. And I think there's some names here of the MICA team that might be familiar to RDA of some folks that have come there in past years. So just want to make sure to acknowledge my excellent collaborators. So a little bit about ICPSR for those of you that might not be familiar. So like I said, ICPSR, it's one of the worst acronyms that I've encountered. It is the Inter-University Consortium for Social and Political Research. It's an extensive social science data repository that was established in 1962, and it collects, curates, and disseminates data in a really broad range of social science disciplines. It houses over 250,000 files and contains 21 specialized collections, and it gets funding from its over 780 member organizations. So those are universities and private research foundations that have basically bought into ICPSR as members, and that's how they get access to their data. It's a very unique funding model, which I would love to see replicated in other places, but like I said, they've been around since 1962, so they've been building this for a really long time. Let's see. So this project, like I said, the goal of it was to understand the impact of data curation and also to think about how do we make data curation more effective. Because ICPSR does have these really robust data curation services, we had a lot of different data points to pull from this. So we use this mixed methods approach. First, we did computational and statistical analysis of curation logs. So ICPSR uses JIRA, which is this like workflow management software, or to basically coordinate work amongst their data curators. And they also have what are called PH files. They're processing history files. So this long, very structured documentation of what goes into the processing of every single data set in ICPSR. And so we did first some computational and statistical analysis of these logs to understand what was the most common kind of curation work being done, how much time was being spent on different curation tasks. And eventually we then tied those curatorial actions to reuse of the data sets to see if there was an impact of one particular kind of data curation on reuse. And so there's a Libby Hempel et al. Paper that talks about that. I'm not going to talk about that here. What I'm mostly talking about in this talk is the results of our qualitative interviews with ICPSR stakeholders, including their funders, researchers, curators, project managers, archive directors, and reusers. So the relevance for this session, I think what I would want to argue is that what you guys are talking about as data review is done in the process of data curation at ICPSR and indeed at a lot of other repositories that have robust in-house data curation services. So ICPSR, in some ways, they're a bad case study because their data curation services are so robust. At the time of our interviews, they had 32 full-time data curators working, which is amazing. I don't think I've heard of another organization that has that many full-time data curators working, as well as 5 curation supervisors, and then additional project managers, people maintaining bibliographies, things like that. Data curators, they're entry level but skilled workers. So they typically hold bachelor's degrees and have experience with statistical software, data preparation, and social science research methods. I'm going to pause because it seems like there's lost power in the room. If you guys can still hear me in the room, I'll keep talking. I will share the slides after this. I'll try to upload them to Whova. I'm not sure if I can do that or if I can get Bob to do it. I'm going to wait till someone in the room tells me to start talking again.
Andrea, while we're waiting, sorry, this is someone just breaking in from the Netherlands.
Oh, no. Yeah, might as well.
There's some people in the chat asking, could we get the link to your slides? Because we're very interested, and also in the paper. And I saw that there would be a link in the slides. So
I can share the paper easily. I'll have to upload the slides because I will confess to having edited them immediately before I started talking. So they're not
as
online.
we all do. But yeah, if you could share a link to the article, that would be great.
Yeah. And
Thanks.
it's an open access article. So
thanks. Great.
So sorry to interrupt. We lost power here in the building again. So now everybody's just going to Zoom until they can restore the power.
Okay, Bob. Tell me when I should start talking again.
Yeah, I would say just you should say in here, everybody's getting on Zoom. I think I will mute.
So I should start presenting again. I'm sorry, there was an echo, so I didn't hear it.
Recording in progress.
Yes. Oh wait, what's happening? Yeah, please continue, Andrea. Sorry for this.
Oh no, all good. I talked through the pandemic. I'm now good at dealing with Zoom interruptions. Okay, sharing desktop. All right, great. Can you see my slides?
We see them now.
Okay, great. Okay, so yeah, like I said, so ICPSR is both a good case study because they have these robust data curation services, but also a non-representative case study because they do have such a huge full-time staff. I think what I was saying before is that I see data review as being a process of data curation as it is done at ICPSR. So there's a good number of curatorial tasks that the curators do at ICPSR that overlap with data review. So that includes things like reviewing data for sensitivity and re-identification risk, because so this is social science data. There's a lot of potentially personally identifiable information in there. Especially like some of ICPSR's collections, I think they're the home of the, anyway, they're of a couple of surveys that are looking at sensitive populations in the US. So they want to make sure that they're not putting their participants in danger. Curators also generate metadata, identify missing values, index variables for future search and discovery. That's a really big deal to making their repository more searchable. And doing things like generating data files in multiple formats. So like I said at the beginning of this talk, I want to complicate workflow perspectives of data curation a little bit. So when we started talking to the ICPSR curators, we tried to understand, like, what are your work processes? How do you curate data on a day-to-day basis? And so I'm an information science professor. I, like probably many of you, are very familiar with the litany of data lifecycle models that we've seen in our field, mostly because I teach them. So we have this one from the USGS. We have this looming Eye of Sauron / meatball from IDCC. This one is my student's favorite. A much more simpler one from Data One, slightly more complicated from the Data Documentation Initiative. And this as my favorite, most complicated one that I think I've found, from the Infrastructure for Integration and Structural Sciences. So we were kind of expecting to find something resembling a workflow in how the ICPSR curators talked about their processes. And what we discovered is that while there is a set kind of task, like there's set categories of tasks of work that they do, there's not necessarily a set sequence all the time. So we wound up producing less of a workflow, more of a taxonomy. And I'm sorry if this figure is a little bit hard to see. It is in the paper, so you can zoom in on it if you'd like to see. But these are the main categories of tasks that we got from the interviews and from doing text mining of the JIRA tickets. So first, curators start with some initial review and planning like reviewing the files, planning on what they're going to do, and also thinking about how much money have they had budgeted to this particular curatorial project, and which I'll get into in a second. There's different levels of curation that they adhere to depending on how much funding they have for a given project. They create metadata, so that is doing things like describing variables and creating survey question text. So like writing out the survey questions so people can search on that. They make additional documentation such as code books, recording changes and limitations to of something like limitations of a data set, things like that. They do a lot of data transformation, so moving things from one format to another, renaming or adding variables. And that does include some almost like observation level data curation, so data cleaning. And they, of course, do a ton of quality checks. So checking for completeness, checking adherence to standards. But so there's this broad category of things. And we didn't put it in a workflow because the work itself is quite iterative, and it's really dependent on the curator and their personal decisions and how they decide to do things and the needs of the data set. We also didn't put it in a workflow though, because we found these additional kind of important tasks that often get ignored in workflow models that we wanted to make sure to surface. So things like coordination. So making sure the curators were talking to the supervisors, who were talking to the project managers, who were talking to the PIs of the projects that were depositing the data. So just making sure that all of this work was going on. Communication, emailing, going to meetings, making sure that everybody was on the same page about different projects, and then just other non-curation work that you do in the course of being part of an organization. And so I think looking through the JIRA tickets is what allowed us to see this kind of work in a way that we couldn't have gotten just from interviews alone. So that was a really valuable part of that method. Looking at the JIRA tickets also, or the PH files, I think this was from the JIRA tickets actually, but it allowed us to calculate a rough approximation of the total number of hours spent on each of these tasks. And I've highlighted the two tasks that I think are probably the most related to data review. So that's quality checks, and that took a full quarter of their time, and data transformation, which took another quarter of their time. So I think the takeaway here is that this is a very time-intensive sort of process. Which will, I don't know, I do some work in scholarly communication, thinking about like the crumbling infrastructure for peer review. It's a big ask of people to do this kind of work as volunteers. Okay, so if ICPSR isn't really adhering to a workflow, how do they structure their work? Some of it is structured through their own internal guidelines. So ICPSR has 3 levels of curation that they offer for their services. Level 1 is the lowest level. Level 3 is the most intensive. And the level of curation is guided, like I said before, through funding, largely. So is the curation of this data set being funded by a federal department, a federal government, or is it a sole PI who has limited money? So basically, level 1 is the most basic one, and that's making sure that the variable names are getting added to the ICPSR database, using a standard ICPSR codebook, and creating a study homepage. Level 3 includes additional usability improvements, and you can see that this is a little bit of it's a little bit of a vague wording. So level 3 is kind of reserved for projects that just are idiosyncratic and need more curation for some sort of disciplinary reason. And I think the other thing that guides what level applies, sometimes they get data that's just already more curated, which means that they don't have to spend as much work on it as well. So there might be some cases where they're doing tasks that technically are level 3 curation, but it was for a data set that came in very good shape. So it's not taking them additional time. So that's another consideration in how they structure their work. Work is also guided by disciplinary best practices. So they use like DDI metadata. They follow a lot of standard digital curation and digital preservation best practices. And that's pretty deeply ingrained in their work practices. But the last thing that structures their work at ICPSR, and this was the main thing that we talked about in this paper, we try to argue that work is structured by the curator's idiosyncratic and personal craft practices. So knowing that workflows are a starting point, not a strict directive. So by craft practices, we mean a gestalt, abstract that representation of the data. So they envision what the final release data set should look like. And then they use their judgment to interpret standards and creatively come up with solutions and thereby achieve a standardized outcome in an unstandardized way. And so I don't have too many slides on this because but there's a lot of quotes like this in the paper. So they say things like, we always say that curation isn't a linear process. That's from one curator. Another one says, I do find that the plan, so this is the processing plan, is useful and it has to be done. And there are things that it walks you through that can help you find missing things or problematic things. But I also rely heavily on just running the frequency output on the data and scrolling through it. I have found things there that I wouldn't have seen otherwise. Another person says, I look at curation as there's these technical aspects, there's do's and don'ts, right and wrong. There's also some artistry or subjectiveness to it and how I might perceive a group of people wanting to view the data. Another person might see it differently. And then finally, another curator says, keeping those standards in mind, sometimes you just have to be creative. If there's something you know users need, you put it in a summary field, you put it in collection notes, you make it more visible. So I think my takeaway for this group is that workflows are useful. However, you need to also make sure that your curators or peer reviewers in some cases have the freedom to draw on their own expertise to do what they need to do to make data usable for your designated community. Craft practices are necessary to manifest best practices. That's how people work the workflow, basically. So some slightly more concrete findings for everyone. Workflow models can only go so far and indeed can be restricting if they're overly mandated. I think it's really helpful to set standards for what an end product should look like, but not necessarily what the process of getting to that end product needs to look like. And I think the last thing is that it's important to treat data curators or data reviewers as skilled craftspeople, not technicians or janitors, which is something that comes up in the literature a lot. And I think I'm a little bit over time and I'm sorry, but yeah, thank you. Happy to answer questions. And here's a link to the paper again, and I'm happy to share slides somehow after this. Did we lose power again?
And data.
So the example is related to the climate modeling community, and I will strive a bit of the upstream, downstream usage of the data because it's really embedded in a long workflow. CMIP7 stands for Coupled Model Intercomparison Project, Phase 7. So it's a project of the World Climate Research Program. And part of their experiments provides the future projections, which are of interest for the IPCC. So for the Intergovernmental Panel on Climate Change, which has started its 7th assessment cycle. And IPCC itself provides policy relevant information every 6 to 7 years in their large assessment cycles. And the last introduction is CMIP7 AR7 Fast Track. So CMIP7 has defined a small subset of experiments together with IPCC, which are relevant for the next assessment cycle. That was one too many. So I have 2 introductory slides. The first point I want to make is that climate science is cross-domain. And what you see here is the timeline of the fast track. I won't explain everything, but just point to the green parts, which say scenarios. Scenarios are really related to the political commitments and the economic developments or expectations. So there are a lot of economic experts involved. And this information, the scenarios feed into the Earth system models, which run the physical climate. So that is more related to physical climate scientists. And downstream, we have usages like downscaling. So that's so they bring the information down to regional or local scales to make them accessible to the impact community. And the last piece, EasyMIP simulation, relates to climate services or domain or sector-specific information. And the last point I want to make, policy relevance. You see the IPCC timeline, and that gets towards this large line in the end, which is called GST 28, and that stands for Global Stocktake. So IPCC provides the information, and that enables politicians to make informed decisions, and these are described in the Global Stocktake, and that is an inventory how far we are of reaching the climate goals of the Paris Agreement. Very quickly, the second introduction of the environment. We are federated in every aspect. So on the left-hand side, this is again CMIP. You see the different modeling centers which provide model data to the federation. So it's really spread nearly worldwide. We have these black spots without any dots in Africa and Latin America, which is really unfortunate. And the right-hand side is the technical perspective. So the Earth System Grid Federation is a federated infrastructure, and it shows the different data nodes. So we have decentral data. But now our topic is review. And I want to make these review points here from the first, starting with the ESGF publication. So when the data becomes publicly available, it's published in the ESGF. And during the publication, we apply basic quality checks, which are mainly compliance to the controlled vocabularies, and the mandatory metadata or essential metadata is provided so that we have some kind of standardization of the data which is available. And the challenge is these checks should not delay the publication, because otherwise they are switched off, commented out, and we won't have any checks. So the second step is the scientific evaluation, which runs after publication. And I will introduce briefly the rapid evaluation framework, which is something new in AR7. Apart from that, I think Bob mentioned it also, the community which starts to use the data does a kind of informal quality check and quality control. So a lot is done there. And we have an errata service where you could check which versions of the data were replaced or superseded. And the last step is the really formal part. So I've introduced that the CMIP data is assessed in the IPCC assessment. And this is a really formal process with 3 formal assessment reports or draft versions of the report. And one challenge I think I will not introduce is that we have increasing numbers of interactive tools. There's a request to have, in addition to the Working Group 1 Interactive Atlas of AR6, additional interactive components. So, as said, I wanted to introduce the rapid evaluation framework, and the left-hand side shows where and what is done as quality checks. I would say the upper side is mainly done by the modeling centers themselves before any data is published. So they verify their results, they validate it against observations which they have. And with this rapid evaluation framework, we have a formal process and consistent process of checking the results. So an evaluation framework, we have long traditions for that, but for AR7, the communities come together to really decide which checks of the quality are essential to judge how good the quality of the data is. So it's really a great achievement, and what is usually done, it's a comparison from a model to an observation or to the model mean, for instance. And in the end, you get all these different results for the different checks, which make up these benchmarking metrics, how we call it. On the right-hand side, you see the infrastructure. So the software development in the ref is open source, and the results are also openly accessible because they are of interest, for instance, for the modeling centers to see if they have to act and change their data, and of course to those who have already used the data that they know there was an issue. And the third step in the review process was this IPCC review. Very briefly, what we have introduced in AR6 was we had, for the first time, the implementation of the FAIR guidelines, which were motivated by enhancing the transparency of the report, so making the creation process for the figures and variables transparent and traceable, so we have provenance information. Credit was very important, and of course preservation of the different digital products and used data. For AR7, the main things are scaling up, more exhaustive data coverage in the archive, machine accessibility is an issue, streamline workflows, better tools for authors, training, but especially what I want to show here is the procedure of IPCC. So we need to embed these requests into the IPCC assessment procedure, and that's shown here. So on the right-hand side, this is an official picture from the IPCC. And where we have to start with intervening is really when the authors are selected, because we need data scientists among the authorship, which then provide not only the figure data, but also the final data, provenance information, how they created these final products. And for that, the refs are important because the evaluation is partly directly used to produce figures. So if we get all the information we request from in these tools, then we really can have a better and machine accessible traceability. The last step is the publication of the report, and there the priority is to document how these figures were created, and that's also related to something which is called complex citation, which will be, there will be a session after lunch in this room. And the idea is to have all the information on provenance and also on the credit for input data in the figure caption with a DOI to a complex citation object which gives access to all these information. I want to make one final point. So I've shown that there is a long process of published data from the first ESGF publication down to when the data is used by the authors. And the last step is really the long-term archival in the repositories, domain repositories of the IPCC data distribution center. So the whole review is done before that. And it's really important to have the traceability. Data is shifted, data products are created by different persons throughout the whole process. So having the traceability captured is really important, and the challenges are right from the start. We have data which is replicated to local repositories, which we call dark archives, so there's no control about the versions which might be used. We have cloud services like Pangeo. We have, as I said, these many steps from the input data to the final result, and we have these interactive products. So we need really to make sure that it is obvious that this image was created by this interactive tool and attach all these provenance information on how this was created. And provenance and traceability is part of the trust into the product, but we also need it, for instance, for the IPCC error protocol to integrate it, because we need the information how this figure was created to identify if there is an error, which other data is affected and needs to be checked. Last point is collaboration is important. I've mentioned the complex citation working group, which we actively were involved in providing a use case and shaping the recommendations, and now having a recommendation within IPCC to use this. And of course, we reach out to sibling assessments to compare our approaches and move forward together. And with that, I just want to announce we have the complex citation working group, so I won't go into detail what we plan for the 7th assessment. Please come back after lunch if you're interested. So thank you. I hope I was not too much over time.
Thank you very much, Martina. This is great. Do we have any questions here for Martina? Immediate questions? None? Any quick questions online for Martina? In the chat? Somebody could speak up if they have a question. No? Okay. Let's just go try. Just click here for a second. And we're going to be setting up the slides for our next speaker, Kirsten Leonard. It'll be Kirsten Leonard is the next speaker. Brief moment to get this set up here. Please be patient with us.
Bob, can you hear me?
Well, Tina.
Bob, can you hear me?
Kirsten, can you please share your screen? speaker, Kirsten Leonard. She's going to be talking about
I don't hear you, Bob, anything.
Okay, so people online are hearing Kirsten, but we're not hearing Kirsten in the room. Can we hear Kirsten in the room?
Whoops. Hmm. I'm not hearing anything from the room, so I'm not sure if I should start.
We can hear you.
Oh, you can. Oh, no. I'm not sure. Okay, I can start. Okay, I have a bit of challenges here as well. Okay, so thanks, Bob. And I think I'm going to try to get through this as fast as possible because I think time has been just challenged with the technical issues. So I'm coming here with a very different perspective, I think, from some of these systems that Andrea presented about, or Martina, having big teams for data review and well-implemented data review. This is the Astromaterials data system, which is a fairly new archive that was built just over the last year. And it needs to implement peer review of data in compliance with NASA's expectations that have for a long time been implemented for the planetary data system, which has performed external peer review of its data. The Astromaterials data system stores lab analytical data of samples returned from space, and it obtains the data both from individual researchers who have research projects funded by NASA, but it also obtains data from missions. That is new at NASA because lab analyses were not considered mission data and therefore did not fall under the same policies as the planetary data system. So we have set up the Astromat data archive or the Astromaterials data system with two different components. One is the repository, or that really stores the data, publishes, archives persistently. And we also then integrate the data into a synthesis to make the data more science or analysis ready. In the repository services, we have a data curation process workflow implemented that is done at the moment entirely manual by a half-time curator. So that's the other end of the spectrum that we're talking about here. The curation process includes a validation of data and metadata, which is primarily a check on the completeness of documentation of methods, data uncertainty, proper unit mention, completeness of data. Some vocabularies are being checked. And then the curators make sure that these metadata are cataloged and indexed and then registered with DOI, and that the landing pages are okay. To some degree, all these requirements that Bob presented earlier, and that came from, I think, slides that he presented at the ESIP meeting this summer, can be considered as being included in our current review process. But some things, and this is here the sort of light-colored arrows, are not yet documented. So we're definitely not compliant in the full range, and we need to establish our procedures. Oops. So our biggest challenges are really getting the whole process implemented. And that is not that we don't know which steps to take, but it's the whole framework in which our repository operates. The biggest challenge is that there are currently no community-wide, globally recommended and governed standards for lab analysis data. So we get different groups saying they have developed standards. It's the usual, 15 different standards for the same data type. So we need to make decisions on how do we set the criteria that we use for our data review. The biggest challenge probably is the diversity of data types. I've shown slides before in this group, I think at the last RDA, that, for example, for the lab analysis of samples from the OSIRIS-REx mission that just came back from space last year, have 65 different methods. So really having a process that has to take into account 65 different metadata requirements is quite difficult. It's a very small research community, so there are clearly not enough people out there to do these reviews of, potentially hundreds or even thousands of data sets coming from missions. And that's our problem. I mean, from the OSIRIS-REx mission so far, we have about 1,000 data sets in the last 6 months. So processing all that with a half-time curator is pretty unrealistic. And we also have a community culture that doesn't quite get excited about reviews and making sure that the data sets are of good quality. And then we're struggling with the fact that the publication workflow for journals needs to be taken into account. Many researchers submit their data only last minute before their article is supposed to be published, and the journal expects the DOI, so we get very little time to actually perform the review. We have started on trying on solutions. And this is just sort of the big items on our agenda. We are engaging very deeply with the astromaterial samples community to understand what common best practices are and to try and advance adoption within the community of those best practices that are already clearly predominant. We are trying to promote more the publication of analytical methods and protocols so that these can be reused for a series of data sets that are coming from the same instrument that was using the same protocol and so on, to help streamline the process. For standards, again, we participate in a global initiative that aims to develop, promote, and govern data standards for lab analytical data called One Geochemistry, but that's going slow, and we need to get started through this extraterrestrial materials analysis group and develop best practices with them. We are also implementing a tool to support the workflow of curation and the workflow of sending data sets out to external reviewers, obtaining the reviews back, and so on. The system is called Kotai. I hope that next time I can actually show you how it's functioning. It's close to to the prototype being available. And we've been talking in the community with other repositories about actually investigating also AI or machine learning methods to support the data review and metadata validation, and potentially organize a working session on this. The current other efforts that we're undertaking is that to create a more comprehensive set of templates for all these different methods, and clearly focusing on those methods that are most frequently used. So the boutique methods for certain specific isotope ratios and so on will have to wait to have perfect guidance for data submission. And we're trying to identify a common set of core metadata that document analytical methodologies. We think that we cannot make the peer review completely mandatory because we simply don't have the resources at the moment. So we want to make it optional, but give recognition for it. For example, by showing a badge on landing pages that says this data set has been peer reviewed. And we want to encourage data providers to suggest external peer reviewers from their community who have the technical expertise to provide a review of the specific data type. We want to engage more broadly with researchers and larger analytical labs to encourage that publication of analytical methods and protocols, as I said, specifically to do that through peer-reviewed journals that focus on the publication of protocols, and then just link data sets to those articles. The other aspect is that of this peer review in the planetary data system, the nodes that do the data curation require projects and missions to have an agreement with them before a data management plan can actually be included in a proposal. And we want to be part of that policy that NASA has, and make sure that any mission or research project has already come to an agreement with us how to address the data review, the quality, the standards that are being used. I think that's it that I had. Yeah, thank you. And I will stop sharing.
Thank you very much. Thank you, Kirsten. So we have a little time for discussion here, and I first would like to ask, do we have any questions for any of the speakers in the room? I don't see any. So let's go online and see if we have any questions online. I saw a few in the chat, but I'm not sure if they were answered in the chat. Is there, if someone has a question online, please go ahead and speak up.
Hello, do you hear me? Can you hear me, Kirsten and Andre? The question is for you, yeah? Okay, perfect. Thank you very much for the talks. I'm a scientist and a neuroscientist. I did a PhD in neuroscience, a postdoc in neuroscience, and now I'm a data curator at a repository. And I'm always wondering what's the real, let's say, interest of institutions, universities, to really educate scientists competent in research data management. Because my feeling at this point is that scientists can name fields whatever they want, can organize files whatever they want, can do whatever they want, and let's just do the curators do the job of organize all the mess we have been producing for years of research. So we scientists, we are trained in experimental techniques, which takes days, weeks, months, years to master. And I'm always wondering why universities don't put efforts to educate competent scientists in research data management to facilitate all these workflows, because as a curator, for me, it will be more easy to receive high quality data sets that you can help to improve a little bit rather than do a complete curation workflow after years of bad data management.
Yeah.
So I'm always wondering, because you are at universities, like what's the role of institutions or graduate schools in improving these competences for scientists?
I think for institutions, it's really difficult to help investigators because of the diversity of disciplines that they're working with. So, you know, you can only to a certain degree give guidance across every discipline that's represented in a university. So it's basically share. Yeah, you should be sharing your data. That's more or less it. And then it needs to dive into the domain specific and data type specific guidelines. So I think that institutions have taken steps, that many of the universities in the meantime have a research data management office, or at least an officer who takes care of that. But as I said, they provide fairly high level guidance. We have worked actually here or had dialogue with Columbia University's research data office. And yeah, they offered sort of a little space for earth science data. But even when you look at earth sciences, you have 20 different repositories and domains, and it becomes really difficult. So it's a challenge, and I see most of the progress we've made through the mandates, the stick from the funders and from the publishers. I mean, that has been our biggest impact, I would say, in the lab analytical data world, is working directly with editors and saying, you know, the data in your journal should really go to a repository that has the expertise to take care of data that come from your lab, that, you know, they understand what needs to be included in documenting provenance and so on. And I see that as the main guidance that universities can provide, is find out who is responsible in your community, take advantage of all the outreach activities that are happening. We have, for the earth sciences, a big international meeting coming up. There is always in the exhibit hall a data help desk where, you know, repositories show how things are done and so on. It's at the moment still, you know, a culture of, oh, data is a second-class citizen and I don't need to care as much. I need to care about my papers.
Yeah, I think a big factor in undergrad education too is we've often suggested, like, what about a data management class as part of like core scientific classes? The question is, what do you not teach? What does that take the place of? You only have so many credits that students take over their degrees. What bio class do you not require anymore? So, and that I agree with Kirsten that the things that have been most effective have been the data sharing mandates and publication mandates from funders and from publishers.
Thank you for the answers.
Thank you very much. Any other questions? Well, I don't see any other questions in the room. Do we have any other questions online?
Yes.
I think it's great
And
to get the perspectives from the different universities, and it would be great to see that some are making some progress in this regard.
could I ask a question?
Okay, not seeing any other questions and seeing that
I have a
we're at the
question.
hour, at the half hour, I want to thank you all for your attention and for your participation in this, and special thanks to all the speakers and the organizers who worked on this, and also to our technical staff and our translators. This is really great, and thank you again all.
Oh, that would be great. I see that people are actually remaining for my question. Thank you so much. Well, anyone who would care to answer. We've just recently acquired a data repository that we can now offer as a central service to our scientists. I work in a large university hospital where we do a lot of research. So we offer a data repository, but the only curation that we do at the moment is checking if there is no violation of privacy, basically, in the data sets that are uploaded. And I see so many beautiful initiatives to take it a step further, but my question to you all would be, what could be my very first next step to improve our data curation?
I can answer that question.
Thanks.
I'm a senior software scientist working in Becker Medical Library at WashU in the US, and I create data set for institutional data repository. We do offer both open and restricted access, and it's a generalist repository, so we can accept any data types. I often use data curation network primers for data types. They list curated steps. If I share the link in the chat, if you
Yeah, I
go
saw
there,
it.
it gives
Thanks.
you a very nice step-by-step instructions. They make the primers available. You can find a lot of data types you might be working with. And it's tricky to do the restricted access. So that's a whole new level. We do not take the, we require them to share the de-identified data set. We don't offer service to de-identify. Once they de-identify, then we can actually check to make sure they actually did remove all the HIPAA identifiers and stuff like that. But I would highly recommend you to check out the DCN website, because it gives you nice self-guidance, and they'll also offer to curate for you at no charge. I hope that helps.
Thanks. Thank you so much.
I would also like to add something. I think that starting by a README file, it's a good first step. So basically asking depositors to include a README file that describes the context and content of the data set, because that allows you first to gather some metadata and some information that is useful for further reuse of the data set. So in the template you include things like authors, funders, methodology, naming conventions of the file, the relationship between the files. And I think that the README file as a standalone object, it's an interesting object to do curation and to get familiarized with the data set. And yeah, I believe that's a very nice starting point.
I agree with you. Actually, that's another thing we do offer. So I don't know if you guys use a data set to issue a DOI, but they will have a metadata schema. So you can create a metadata template, and README is another one. And Cornell is probably by far the best standard for creating a README file. I just shared the example. We do have README template that we ask the depositor to fill out. So 2 requirements: the metadata collection template and the README file. And then ours is a customized version of the Cornell one, but a lot of people use it. So there's a general information, there's a data specific information, the provenance and everything, but we collect a lot of PIDs, persistent unique identifiers, such as ORCID ID for authors, and then ROR for affiliation, and then funder IDs and the grant numbers, etc. So if you are interested, I can share you our README template. Just message me from Hoba and I'll send you the example. Thank you.
Thanks. Thanks so much for the tips.
Definitely, we can stay in contact. One of my jobs is to increase curation capacity, so we can stay in contact. I put my LinkedIn in the chat, so if there's
Thanks.
anything I can
Yeah.
support or collaborate, I will be glad to do so.
I'll connect immediately. Thanks.
Cool.
Thank you all.
Okay, bye.